Hello, everyone. Thanks for joining us. My name is Frank Conkle. I'm the events editor and a tech reporter for Government Executive Media Group. It's my pleasure to welcome you to today's Tech Exec Viewcast titled Roadmapping the Future of Cloud Computing. Events like these would not be possible without the support of our underwriters, so I'd like to take a moment to recognize the exclusive underwriters of today's Viewcast, Intel and Amazon Web Services. A bit later, Government Executive Media Group President Constance Sayers will continue the conversation on the future of cloud computing with Intel's Steve Oren. In just a few minutes, I will turn to you, our viewers, for your questions. You can submit them at any time by tweeting at us during the discussion using the hashtag TechExecViewcast. Now, I'd like to introduce you to our speakers for today. Directly to my left, we have Matt Goodrich. He's the Acting Director for the FedRAMP program at General Services Administration. Next to him, we have Robert Bond, Cloud Computing Program Manager, Advanced Networking Technologies Division, Information Technology Lab for the National Institute of Standards and Technology. And then farthest from me, we have John Messina, Computer Scientist, also for the National Institute of Standards and Technology. I want to let you guys introduce yourself a little bit. Matt, tell us about yourself.
Sure. Great. I work at General Services Administration. Started there about 5 years ago as a member of the Cloud Computing Initiative there, which was under the CIO Council and under the direction of the administration to help agencies move to the cloud. So our direct mission there was to remove the barriers to adoption. We had a few different working groups. I focused mainly on security, and out of that came FedRAMP, which is the mandatory program that agencies must follow when implementing cloud and for security and implementing FISMA on those cloud systems that they deploy. So I now manage and the director of that program.
Oh, we're talking about that quite a bit. Robert.
Thanks, Frank. Hi, I'm Robert Bond. I serve as the program manager for the NIST Cloud Computing Program. In that role, I serve to help develop the direction for the cloud computing program, and we've recently released a cloud computing roadmap which documents 10 requirements in security, interoperability, and portability for quick and fast adoption to the cloud. And I'm sure we'll have time to talk about some of the requirements, et cetera, in that.
Definitely. John?
Hi, my name is John Messina. I'm a senior member of the NIST Cloud Computing Program. My focus over the last several years have been laying the foundational work for cloud computing. We've been developing the work in our public working groups for the vocabulary for cloud computing. We developed the reference architecture, which is a high-level model to make certain everybody can have a more meaningful and useful conversation on cloud computing.
So our speakers today are the guys that also make policy and help with standards and stuff that really allows cloud computing to become part of a conversation in government. So I want to first start with Robert here on talking about a fairly big release they just had on the actual roadmap for cloud computing. Right. So give us a little bit of background, a little bit of history on how NIST fits into cloud computing, when it became an issue as a technology that you guys started paying attention to, and then what the roadmap is.
Sure. So we started a few years back. We actually people at NIST, Peter Mell and Tim Grants, developed the original definition for cloud computing. That's out there on the web. That's what we all had to start with at the very beginning. Then there was a movement from the White House, and Matt can talk to that as well, where we were going to work on developing the standards and technologies and that would enable cloud computing from the NIST perspective. We took that small program. We were able to capture interest from academic people, from industrial and other government agencies, to be inclusive and have a real community type of discussion. What are the issues for cloud in certain areas? We've been able to now produce a final copy of the roadmap for the technology roadmap for cloud computing, and these requirements really show how to go from point A, where we are today, to fully move over to point B, where we have full cloud. Another way of looking at those requirements is just to say, what are the risks that are associated with moving to cloud? So that's another way that the roadmap can actually be looked at when you read it.
So, what are some of the standards or not some of the standards, I should say, what are some of the highlights of the roadmap as you see it? I know you're a standards guy, so that might be one of the ones you want to jump on.
Thank you. Good question. Some of the highlights for the technology roadmap, one way to look at it is that they represent some of the biggest risks for people trying to consider moving to the cloud. And one of the major successes, for example, was service level agreements. It's the underlying contractual agreement with the service agreement for the cloud that most people tend not to think about. But if you go out there in industry, the SLAs from various cloud service providers were all over the map. They didn't use the same terminology. They didn't use the same metrics. They didn't use the same concepts, guarantees. So if you looked at like two cloud services from two different cloud providers, they could be identical in every way. But the underlying SLAs were so completely different, you couldn't really compare the two. And the effort once it was highlighted in the roadmap, it raised awareness, and we got a lot of the cloud service providers to understand that SLAs would be a huge issue. And we finally raised that to the point where we've kicked it off an international standard in the ISO IEC arena to develop that standard to help both consumers and providers.
And they all signed off on it, right?
Yes. For the ISO standard, you have to have countries vote on it. We had like 18 countries vote yes that it was an important standard to develop, and no votes. So it's clearly everybody is now well aware that the SLAs need to be addressed on an international standard level.
So I think one of the things that's important about that, though, when you're looking at, you were saying that, even though the exact service might be the same, but the SLAs are varying different. If you look at the definitions like you're talking about varying, something like uptime or downtime, and saying if you have 99.59s, but they define downtime as any maintenance window, and a maintenance window could be 6 hours every month, you're not reaching 5 nines. And so that really shows how much that can actually impact the service that you're actually receiving, even if it's technically the same service. Those SLAs are really critical to understanding how you're using that cloud service in the end.
Those exemptions can make it big enough that you can drive a truck through.
Exactly.
What do you mean it's been down for 3 days and it doesn't qualify? Well, if you look through the exclusions, of course it doesn't qualify.
All right, so Matt, give us a little more background on the FedRAMP program, some of the successes over the years. You guys have only been around a couple of years, right? And we've had something on the order of, and you can tell me this better, but a lot of cloud solutions have gone through already. And if you're not familiar with FedRAMP, it's basically mandatory. If you're a cloud service provider, you want to get into the government market and build solutions, you're going to deal with Matt and his team. Give us a little bit of background here.
Sure. So the biggest barrier when we were really looking at cloud adoption that everyone said was security. And as we were looking at how to address security, Bob had mentioned Peter Melitnist. He helped us lead one of our security working groups, and I kind of call him the father of FedRAMP. And so he, really had this sort of idea of how do we get a security model that works around cloud, mainly because cloud has, at its core, is multi-tenancy for the most part. There are private clouds that don't quite have as much multi-tenancy in the same definition, but multi-tenancy is a large portion of cloud that agencies are going to be using. So how do we get a standard that every agency can agree to, even though there is the NIST framework for FISMA and the 800 series documents, agencies are still using them inconsistently or sometimes in contradiction with each other. So how do we get that to happen? And FedRAMP sort of organically grew out of that. And really what we did is took the NIST standards of the 800 series documents that agencies were already following in the risk management framework, and then tailored that for cloud so that we could get the most reuse out of that standard. And originally, while FedRAMP's mandatory now and it's a mandatory policy, when we were originally creating it, it wasn't intended to be mandatory. There's such a great business case behind FedRAMP that it makes sense. If you're going to do security, you should do it once and do it well, and then everyone else can reuse that. You shouldn't have to recreate that body of evidence multiple times like we were doing across the federal government. And it became mandatory because if it does make such great business sense, why don't we just say you have to do it?
Yeah, it makes good sense.
And so we launched about 2.5 years ago. To date, we have, I think, 23 providers that are authorized through our program, many more in process. So I think we're up to about 35 in process right now. Of those that are currently authorized, I know that covers well over 500 contracts across the federal government. That's a low number, but I know it's a number I can easily back up. So I think we've reached a pretty good saturation point with only being in 2.5 years, considering these authorizations can take anywhere from, at the very, very low end, for a very simple one, 4 months, all the way up to 12 to 13 months. So we've really only had about less than 2 years of actual authorizations that have actually been through. So I think we've got a pretty good number, some really great players.
Many more in the pipeline, too.
Yeah, many more in the pipeline. Most of the key players that you would expect to see in the space are either authorized or very close to being authorized. And again, all the way from infrastructure all the way up to the software layer as well.
And I've heard you toss around a savings figure before a couple times. Is it $200,000 that you mentioned?
Costs about $250,000 from the government side to authorize, to go through this process. It's a pretty arduous process for providers, so that's not even touching what providers have to pay, and that really depends on how well everything's documented at a provider or not. But it costs the government in our cycles approximately $250,000, and that's based off of FSMA reporting and other data sources. So as we go through and look at the number of FSMA instances that we know of, if we are reusing these security assessments, I know there's at least 160 FSMA systems that reside in the FedRAMP authorized systems. So if you take $250,000, multiply that by 160, that's roughly $40 million in cost avoidance. So that's a very safe number. I'd say the $250,000 is probably a low estimate, but it's an estimate I can very easily back up. And the 160, again, I think is still a low estimate, but one that we know shows significant progress and significant cost avoidance for the program.
We'll come back to FedRAMP a little bit because there's some more interesting news coming out of that program office shortly. But I wanted to get back to our NIST fellows here and talk a little bit about, we've already touched on security and we'll continue to, but in the roadmap we talk a lot about other things like interoperability, portability. I'd love for you guys to shine some light on what that means going forward, because those are topics at the high level that don't get as much attention or as much headlines, if you will, in how government is moving to cloud. So let's talk about some of those.
Sure.
Some of those IT-wise.
Sure. So basically, when someone wants to go move into cloud and they take their apps and they take their data and they move it into the cloud. Okay, so now everything is working well. You've got everything tested out, but then you might have some situation with your provider where you might want to then say, okay, I want to move back out of the cloud. At this point, you have you might have a situation in which the data is not really usable to you any longer, right? So you need to have a exit strategy so you could get your data back in a usable form. The interoperability and portability aspects allow you then to say, I can safely put my data in, and I know I can safely return it back to me, right? Because of the portability aspect. I can also then use the data. If the clouds are interoperable and portable, then I can use secondary clouds in the background to take up more cycles and to be able to still work properly and seamlessly. So that's a fundamental aspect of the cloud computing framework. I'll let John discuss a little bit more on that.
So one of the major things, as Bob mentioned, is the ability for people to pull back out of the cloud or move clouds. But one important aspect that typically gets forgotten is that everybody wants to take the full advantage of cloud computing. So cost savings, like Mac was talking about. What happens if I go to a cloud service provider and they offer a specific price, but over time it goes up or there's another competitor out there? So you want those portability and interoperability, typically backed by standards, to allow you to have free mobility in the cloud marketplace. That's where you're going to get a lot of the maximum benefits of cloud computing. You can go to the provider that suddenly has the newest innovative system that addresses your business needs. You can go to ones that are more cost competitive. And because cloud computing is so dynamic, it can be very short-term operations. You could acquire a cloud service for a specific need that you only need for one day. Then you have a dynamic marketplace if you have all these interoperability and portability issues are addressed. You can hop around as needed to best meet your business needs.
So I think one thing to add to that is the interoperability, as you're talking, moving from one provider to another is interesting, but also there's a huge shift in the way that I think a lot of agencies are actually using cloud in terms of a hybrid use of cloud. You had mentioned functionally how they interoperate together, not necessarily that you're leaving one service to go to another service provider, but that your service providers can interact together well. Like if you're doing your dev in a cloud and you want to put it in production here, but you want the databases to still be on site, how does that all work together? And I think that's where a lot of agencies are looking, because there's not, I think a lot of agencies are seeing there's some cloud providers that do one portion of what they want to do really well, and another cloud provider does this really well, and another portion does this really well, or the pricing is significantly different for the services they want to use, and they want them to all work together seamlessly, and that's where we're still needing the providers to catch up, because so much of what they've developed has been developed well because they do it themselves, and they've built this market, but it's so proprietary that they don't interoperate well. And that's where a lot of the government agencies are looking for some of that standards to begin to help with that.
Some of the stats I've heard about that is upwards of 80% of all cloud services in the future are going to be consumed by other cloud services, both internal to an organization and across cloud service providers. So there is a huge need for not just interoperability and portability, but specific types of interoperability and portability. Not to go back to standards, but I do it a lot. We've also kicked off the new interoperability and portability standard in the ISO IEC, and some of the earliest activities in it, we've identified at minimum 12 different types of interoperability and 12 different types of portability that we need to discuss. So that standard is going to do the highest level so that when we deal with contracts, you can not just say, I want it to be portable, but you can be more specific about the types of portability that you need and the types of interoperability that you're going to need out of the cloud service.
It sounds like you're going to be busy writing standards for
Yes.
quite some time with cloud.
Quite busy.
We were
This
first.
is not going out of business.
Yeah, no kidding. We have a first audience question, and I should remind everyone that you can tweet these Tech Exec Viewcast and ask these guys, put them on the spot. This one is, I think, directed at all of you. Anyone can answer. It's what is on the horizon for the intersection of cloud and IT with more and varied hardware consuming bandwidth? So whoever, and that's from Rick Cagle, I think, who just sent that in. Anybody want to?
I think it just backs up to the point of, I think, as more and more agencies are moving larger and larger and more mission critical applications to the cloud, more enterprise-wide solutions to the cloud and enterprise-wide use, is though that sort of hybrid approach like we were talking about of how do we actually use more and more cloud and how do they all work together is really where I see a vast majority of agency cloud use going, is not just stovepiping sort of this use of this one provider for this one service, but how do all of these services that I want to do across my enterprise, how can they functionally work together to create a sort of comprehensive solution set for my agency that we can use all of these services and seamlessly use them. And that's where I think a lot of agencies are really striving to get to.
And cloud is not a terribly rigid thing, right? I mean, you guys at NIST have authored a definition of it a couple of years ago, but it's not something that's entirely a straight line, correct?
Right. In fact, although we have that definition and we developed a reference architecture, it was important to understand the reference architecture that we developed is something that's based on actors, which describes what do you need to get cloud computing moving, and not a how, which is a implementation pathway. Thou shalt do it this way. So we left that open for innovation to occur. Now, back to the question about additional hardware. So perhaps this is a outcome of how big data will be approached in the future. Killer apps for big data. You still need the compute power in the background. The cloud will allow you to grab disparate parts of disparate data sets and pull them together.
That's a really good point. And John, we talked a little bit prior to this conversation on big data as a driver for cloud, because the more portability you have, the more access you have to data sets you may have not had access to, correct?
Right. One of the whole benefits of big data is that you want to crunch huge amounts of numbers and data to find that small nugget of information that will make the most sense for your business need, whether or not you're doing research or trying to identify some sort of correlation. But these data sets are so huge, they tend to reside in one cloud service provider. So say you're a researcher and you want to access multiple ones, where you're going to need that interoperability so that you can do your searches not just in one cloud service provider, but multiple ones. So in essence, you need that interoperability to access that huge data set, so then you can develop all these new additional nuggets of knowledge that will help you with your business concerns.
Another question that has to do with contracting, and that's just on how can we improve contracting in this area? I'm guessing they mean cloud computing. How will contracting get better in government as emerging technologies evolve? That's an interesting question.
Yeah, I think there's a lot of activity going on. I mean, I think It's no shock, I think, to everyone that the way that the government purchases does not particularly align perfectly with cloud computing.
Right.
And I think there's two elements to that, though, of what makes it particularly complicated for contracting in the government. One is the way we buy with the FAR, and the way that we spend money and obligate money isn't on the same consumption model that we use with cloud, or that cloud tries to get to. So really sort of aligning how we can do a consumption-based model with the way that the government has yearly funds that we obligate a certain amount to a contract, and how we can create flexibility within that. There's some great examples of that happening across the government, either at HHS, at DHS, at NASA. There's a lot of agencies who are doing really great things, and I think that's an easy part to solve. I think the harder part, though, the second portion of it that's difficult, is the budget process, and how do you actually spend money when, right now we're under a continuing resolution. What's going to happen next week if we have another shutdown and we don't have money to spend? And that affects how we can actually obligate money and anti-deficiency rules and things like that. So the budgeting portion's, I think, a lot harder to grapple with, but I think the contracting is catching up, and the FAR is flexible enough. I mean, we are buying utilities as it is anyway. We purchase electricity for our buildings. We know how to do it. It's really making sure that we're having people effectively look at the FAR and understand that, and there's a lot of agencies that are beginning to do there and get there. But the budgeting side is will continue to be a struggle, and I think there's got to be some forward movement on that soon.
Do you guys take up the issue of contracting as you're coming up with standards?
It certainly plays a role in a lot of the discussions that we're having for the standards. One of the things that comes up most is, service agreements have been around for, more than 30 years? But they tend to be monolithic and static affairs. You set up a broad contract with the customers, and then you stay with it for long periods of time. Cloud computing by itself is highly dynamic. You can get to the point where you just consume a little bit and then you're done. So how do you you don't want to take the time and effort to put up these monolithic contracts. You want to be able to do one-off ones, or you want the ability for them to be dynamic and change over the course. And that's not typically something that a lot of companies outside the government are even set up to do. So what we're trying to do, at least in the international standards arena, is make them flexible and modular so that people will be able to set them up to better reflect the dynamics of cloud computing. At a longer term, we're looking more like 10 years out, is that ultimately, if they're all standards-based, the idea is that we want to get to the point where they can become fully automated. You'd have computer programs that would then be able to generate service-level agreements, for example. You'd have the two companies be able to talk, identify if there's any sort of common ground that they might have, and then automatically generate an SLA. But that is a little bit farther
That's
off.
a fascinating point, though. You'd have algorithms deciding who gets to use what resources and things like that. Very fascinating. You've talked about cloud of clouds before, but how does this apply directly in the federal space? You mentioned portability. We'll probably hit on that again. But if I'm X agency and I don't have a huge budget and I want to get into cloud and I want access to some extra data sets that maybe I could have access to that are there, but I don't know how to get them, how does Cloud of Clouds fit into the federal space?
Well, the Cloud of Clouds, which is really the seamless integration between various clouds, requires that everybody has a common set of technology tools, and they agree upon a set of APIs. I mean, if you throw back to the early days of email, you might have multiple email providers that each had their own standards, their own protocols, and you couldn't send email from one email provider to another one. So we have to get to the point where you can agree upon a common set of standards, tools, and technologies. Then you can have that seamless integration, and then it would make it fairly easy for government agencies to access each other's cloud services. In the private industry, you're going to have to come to some sort of common consensus. There's no organization that can come out there and say everybody must use these set of standards and APIs. Within the federal government, you could have a push from down to the individual departments and agencies saying, well, you need to apply these standards or make use of these APIs and tools. And then you could create an environment where it would be much easier to make use of each other's cloud services.
Right. The roadmap really promotes agility as we go forward then. I mean, that's the whole point of what we can see and use cloud computing for. And you guys have both highlighted uses where, you spin up a cloud and you need it maybe for disaster recovery. I can think of like a FEMA example where, a Hurricane Sandy hits and you need something that can process terabytes or plus data on short order, right? that's a great use case for cloud, but when you're done with it, you're not going to need it forever, right? You're not investing long-term. It's a short-term investment. So having these kind of standards, forward-thinking, really sets the tone for where we want to go, I think, especially on the government side. And private sector is doing this a little bit, but it's fascinating to see. We have another question here from Twitter, and it's you guys probably are all familiar with Internet of Things, right? The concept. It says, can you comment on plans for all panels? Can you comment on plans for cloud and the Internet of Things? What changes are you anticipating? I guess how is Internet of Things going to affect you guys moving forward? We're talking about connectivity. I don't know. There's all kinds of statistics out there, but Cisco's saying 80 billion internet-connected devices coming soon, by 2020. I think it is. Absurd amount of connectivity between everything, sensors, all this kind of data, all pulling it together. What does it mean?
So before you go on the standards portion, to me it scares the shit out of me. It scares the crap out of me because I have no idea. As we try and do a security and create a boundary around things, Internet of Things expands that boundary exponentially. So there's connection points everywhere. So it's something we're going to have a lot of work to actually to figure out and wrap our head around as we, mobile and cellular and tablets is something that's becoming a big issue for us. I mean, Internet of Things expands that way beyond just the connectivity of cellular. So you start to look at literally just not even someone that a person's touching, but is these, just inanimate objects talking back and forth of the system that's not in my boundary. That becomes a lot different of a perspective of a boundary for security. And it's something I think the security world is going to have a sort of a huge shift in the way we think about it and look at it as we start really moving towards Internet of Things.
You think of not just your mobile devices, which already outnumber people, by the way. I mean, we recently hit that benchmark, I think, in 2013, where now there's more mobile devices than there are actual human beings on planet Earth, which is crazy to think about. But now you're talking about cars, refrigerators connected to a Wi-Fi network in your home, picture frames, now parts of your body with Fitbits and things like that. As those technologies expand, Google Glass, everything produces some kind of data for one purpose or another. Even pacemakers, I believe they've been in headlines before too, because doctors want access to the data that pacemakers are producing. Should they have to go in and cut you to get it? Maybe it's safe to let that send out through the internet. Maybe not. From you guys' perspectives, though, as sort of forward-thinking standards folks, how does it affect you?
Sure. So the first thing that I think about is the quantity of data that's going to be produced. Where is this data going to be stored? We could develop technologies called cloudlets, which would basically be a cloud on every block, right? That would be collecting the data and that could be used to push out data. For example, the cloudlet, if you're walking down the block and you're looking at some website or something and you on your mobile device and you could flick back and forth through the hyperlinks, that cloud would then, the main cloud that would send the data would send it to the cloudlet. The cloudlet would then be a local data repository for you specifically. And as you move, like in mobile technology, when you have a mobile cell tower, your data would then go along to the next cloudlet to make sure that you had fast access to your data, because one of the key things is, right, the network traffic, and you want to reduce the time for network traffic. If I don't have to go out to a major site in Oregon or Washington State every time to get my data, I could just go grab it once. The data can become locally to me and then follow me where I go. So that's one aspect of how cloud, or like I say, the cloudlet will be a different way of perceiving cloud. But certainly the Internet of Things holds a lot of promise as well. It also holds the way of how will people interact with things.
Does it scare you like it scares Matt? Either of you? Does it scare
No,
you?
we're not scared.
We're good.
Not-
We got this. We're
No,
good.
we're geeks.
Leave it to this. I got our.
Not scared, but impressed by the amount of work that it'll take to get the Internet of Things properly working.
Right.
So you have all these devices from all these different manufacturers. They're not going to speak the same language.
These are questions that you, in our conversation, I would think would ask, right?
Right. So you would have to agree on a set of APIs. So you can do incredible things if you have the Internet of Things. I know some countries are looking at it in terms of sensors, like disaster recovery. You'd be able to identify a disaster happening earlier and takes responses, maybe push Twitter messages out to people in an affected area saying this is what's going on. But you'd still need to lay the groundwork so that all these devices can actually talk to each other. Otherwise, there's going to be I forget what the number would be, billions of voices all in different languages, and you wouldn't be able to make sense of it.
Yeah, well, Stanford just recently held their first trillion sensor conference, and their premise was that in the near future, I think it was like 10 years or so, that we'll have 1 trillion sensors out there. Now, not all of them are going to be web connected, but I mean, you can just imagine the amount of information that would put out. It's astounding, really. One other question here that comes in. I want to get back to FedRAMP in a second because you have some news, but. Is government ever going to run entirely or almost entirely on cloud?
I mean, when Vivek started the cloud first policy in his 25-point plan to reform federal IT, they only identified 25% of federal IT that could actually potentially move to the cloud. I think my thought is that's still probably a little bit low, but I don't think the cloud is right for everything. I don't think it's right for commercial sector for everything the commercial sector is doing. There's still going to be instances where we're going to want to have to maintain more specific control over that data, or times where we don't need all of the benefits of cloud because it's a more stale data set or something. We just don't need all of that there, and it could be cheaper to store that data in another way. So I don't think cloud is appropriate for everything, but I think it's becoming more and more appropriate for more and more types of data than it maybe was than we thought it could have been 4 or 5 years ago. I think there's probably a greater percentage that's becoming more appropriate for cloud. But I don't think that cloud is going to be the end-all, cure-all for everything that we want to do with IT and government.
Any thoughts from you guys on that question?
Right. Well, so my feeling is 4 or 5 years ago, the cloud was virtually absent from the federal portfolio. We've seen a burst of it in the past 4 or 5 years. I still see steady growth occurring. Eventually, some other technology might come along and take over cloud, or use the lessons that have been learned with cloud. So something new doesn't ignore the past. But I see cloud rising up in the government, and it's only we're only strained by the limits of our imagination and creativity how we decide to move cloud.
Well, I think the other interesting part about cloud too, though, is the cloud's a new term, but cloud isn't necessarily a new technology. It's really sort of an evolution of technology, and almost in a weird way a return to the sort of server mainframe way that we started out doing technology. Right. So I think that's a sort of cloud's the new sexy term to use about this new way to deliver IT, but it's not new IT. It's just a sort of reconfiguration of different developments in IT to be able to deliver it more effectively and more cost efficiently, and have sort of these new services pop up and be able to access them faster.
In that sense, cloud computing is just a tool. You have to decide whether or not it makes sense for any given application. But cloud computing is largely becoming an infrastructure, kind of like the internet in general. So it's laying down the infrastructure that people will then be able to make new applications on top of it. Like big data naturally fits into cloud computing.
Right.
So as cloud computing becomes more ubiquitous in terms of infrastructure, it'll be all that innovative new processes, services, jobs, opportunities will be built on top of it.
Yeah, I think spending-wise, I mean, 4 years ago you had almost nil, and now we're in the, not quite 10 billion, but in the billions of dollars of I think it's like 2 or 3 billion right now that we know for sure is being spent on the federal side of cloud computing. So clearly the market's ballooned, and going by any statistic that you want, the future is only going to keep increasing. I don't know where the ceiling will be, but I guess that remains to be seen. Technology changes so quickly that, how do we really know? getting back to the FedRAMP program, and you guys have built that off NIST standards 853, and there was a 853 third revision, and then where there's a fourth revision that was released last year, correct? Mm-hmm. Then you guys revamped the standards again this last summer, I believe. Mm-hmm. Where's the program heading now? You guys have some new standards you're working on, correct?
So we will always default to NIST standards. We never wanted to change within FedRAMP how the federal government operated under security authorization. So in order to implement FISMA, you must follow the NIST standards. So we follow the NIST standards for that as well, and we will always do that. So that's why we updated from Revision 3 to Revision 4 for our security controls. But right now we only cover low and moderate data impact levels, and that's, low is basically public data. Moderate impact gets into personally identifiable information and sort of that general, a little bit higher security. But we haven't touched high impact levels yet within FedRAMP. Low and moderate systems cover about 80% of the federal systems in the government, but then about 80% of spend actually goes towards high systems. So high systems are significantly more expensive, but it's also because there's significant more security and sensitivity around the data. And so we're looking at finally developing a high baseline as we're seeing more appetite by agencies to move some of those more sensitive applications and data sets to the cloud. So we're looking at actually having that high standard and baseline created. We'll probably have something out at the beginning of the new year, so sometime in January for our first round of public comment to actually start to develop that. So we're working internally to government right now with the key stakeholders among those high systems that have a vast majority of those to get a somewhat of a government consensus internally before we put something out for draft. We're finalizing that this month and should have something out in January to begin at least one round. I mean, it's going to be at least 2 rounds of public comment, but the first round will start in January for that.
Then existing cloud service providers that have gone through the current FedRAMP process as it is, or started going for the fourth revision, how will that change? Will they be able to use what they've already done, those assessments, or how? Give me a little background on how that will work.
So the NIST, the update from Revision 3 to Revision 4 really reflected sort of the way technology is occurring now. So my favorite example of that from Revision 3 to Revision 4 is the Trusted Path security control that was in Revision 3 that's not in Revision 4. And Trusted Path was essentially you had 2 data centers, and we literally wanted to see the connection from this data center to this data center, and like what was that path? Like what was the physical cable connecting the two? And that's no longer the way we really look at the internet and look at the way that data flows. And so now we look at non-repudiation, things like that, of how basically the intent of that was you have one data packet going from this data center to this data center. How do I ensure that when it leaves this data center, it gets to where it's supposed to go, it hasn't changed when it arrives there, and no one's done anything to it? So the security controls really reflected that shift in technology from some of that more traditional to generally what's the intent of these security controls and how are providers actually implementing it. And so that's really the update from Revision 3 to Revision 4. In terms of capabilities, I don't think it impacts what providers are actually doing, but it's actually describing what they're doing, and not in alternative ways, but actually addressing the control and updating that. So we have a transition plan on our website on fedramp.gov that details how providers can transition from Rev 3 to Rev 4. We have annual assessments that we do through our continuous monitoring and oversight of the authorizations. So at providers who are already authorized, at their next annual assessment, they will have to transition from their original Revision 3 to Revision 4.
Okay. So
that they'll be in alignment with those new requirements.
I think it'd be remiss if we didn't talk a little bit more about security. And there was a recent, forward-thinking prediction from Forrester that came out. And one of the things, it was based on cloud computing, so what's going to happen in 15. And one of the ones that caught my eye that stood out was a line they have in their report that said, you will have a data breach, and it will be your fault. And so I wanted to just ask you guys. Yeah, your fault. That's what they said. So I'm looking at this from a federal perspective if I'm an agency IT manager somewhere. And data breaches have gotten a lot of headlines lately. I don't think ever before I've seen this many in one year where you have large-scale headlines coming from your Targets of the world and these big companies, Home Depots. And even in our own government, we've had, headlines where White House, State Department, we see them more and more commonly. What, from you guys' backgrounds here, how do we view data breaches? How do we view that? What do you got? What goes on in your mind when you see these kinds of headlines? how do you guys react to them? And can we fully expect, down the line in a couple of years that we won't have as many of these types of issues, or will we for sure?
Well, I'd like to speak then. What I see is I see that one bad guy made his one hit, right? Whereas industry and government and academia, we have to make sure we're right all the time to keep the barrier from the attacker, right? So he has a lot of some of these attackers really have a lot of resources of their very own, and they also have specializations, right, where they have their own market and they procure services from each other. We know that you're an expert in this type of hacking or this type of hacking. So what we have to do is to work stronger across with industry and government to look at these vulnerabilities, right? And when it happens, how can we start to address it? I'm getting an attack like this. Did you see an attack like this? So now we have to work very strongly in a way that we may not have worked before in order to keep one step ahead of the attackers.
I'll tackle a tiny portion of that question, focusing more on the small and medium businesses. One of the benefits of moving to cloud computing is that you don't necessarily have to put up the capital resources for the infrastructure, the IT expertise to maintain your own internal systems. So for some of the small and medium businesses out there, it would make sense to move to cloud computing because the cloud service providers would have more technical staff on hand to better ensure the security of the data.
Right. So I think another part of that too, though, is a hack is the exploit of a vulnerability. Right? So anytime there's a hack, that means there's some vulnerable portion that was actually exploited by a bad actor. We are never going to get rid of bad actors. There's always going to be bad people out there that want to do bad things with our data. And as the government, we have more sensitive data and things that we have a higher calling to make sure that we protect that data. It's citizen data. It's very important data to us and to the country. And so we are always having to protect against those bad actors. But as we're doing it and developing the security standards, if you look at what NIST has put out and what we operate under, it's a risk management framework. Those risks are always going to be there. And what makes the story is the one time that a hack happens. What doesn't make the story is the 500,000 times that we defended against attack that didn't actually happen. And so, yes, a breach is going to occur. There's always going to be bad actors, but it's how few are we going to have versus how many are we going to have. And so that's where we look at things like stronger identity and access control management and things like that, and how do people authenticate into a system, and how do we prevent weak authentication where people can just use a username and password, but instead you have to use a PIV or a CAT card to actually get in as well. So really looking at how do we reduce the number of vulnerabilities and our oversight of that. So if you look at recent zero-day attack or zero-day types of vulnerabilities like Heartbleed, it was really I thought heartening for me, looking at our cloud providers that we've authorized under FedRAMP, how proactive they were at actually taking care of those vulnerabilities before there were actual exploits of that, so that there weren't any breaches. And so how fast that needed to be taken care of, and how actually critical it is to many of our cloud providers' business to actually take care of that, and so that they aren't part of the source of those hacks and those exploits happening.
Exactly. They're very responsive.
Yeah, so they've been very reactive, and I think it's been something that, again, yes, a hack will occur. It's at this point a risk management framework, and how few are we going to have versus how many, and that's really where we have to focus.
Yeah, you focus on the pros that we had talked a little bit about earlier, the pros of what cloud allows for, cost savings, efficiency, but the risk, there's always going to be a risk. Your goal as an organization is to determine what risk is acceptable for you and what isn't. We see the Defense Department now, the slowest, called laggards to cloud, but even they're on this ball now where they're looking at what is okay for us, and they're expanding what they're allowing for in the Defense Department, which is interesting for everyone, I think. I wanted to, since we gave a little future talk about where FedRAMP's going, I want to give you guys a chance to talk about what the next roadmap will be. What else are you guys looking at within NIST going forward? What's your line of work?
Sure. So along that dovetails with the SLA work, we've also been working on a model to develop cloud service metrics right? So, when John talks about an SLA, he's talking about a service level agreement that says how much of what you're going to buy or what you can expect. We're putting out a draft document in the next week or two where we're going to be asking for comments from the public on the model that we've developed. For example, uptime, downtime. Matt used an example like that earlier. We're starting to work out the concepts for how to develop metrics like that. So that's one of the big things that I'm looking forward to in the past year, in the following year.
Okay. John, close up.
We have multiple standards in the pipeline, which is fantastic. They'll be coming out anywhere starting from 18 months out to 3 to 5 years, and it should greatly assist the cloud industry.
Okay. I'd like to thank our speakers today, Robert Bond, Matt Goodrich, John Messina. Really appreciate having you guys. Stay tuned with us. We're going to continue the conversation. Constance Sayers, our president of Government Executive Media Group, is going to continue this in just a minute.
Thanks so much to our panel for that interesting discussion, and thanks to our audience for tuning in today. I'm Constance Sayers. I am the president of Government Executive Media Group, and I'm here with Steve Oren. Steve is the chief technologist for Intel Corp's Intel Federal. We're going to continue the conversation on the future of cloud computing, but first a few words about Steve. Steve is responsible for cybersecurity and cloud strategy, architecture, and engagements. He's held architectural leadership positions at Intel, where he's led strategy and projects on identity, cloud virtualization security, anti-malware, and HTML5 security. He's a recognized expert and frequent lecturer on enterprise security and was named one of InfoWorld's top 25 CTOs of 2004, and in 2009 was named a fellow at the Center for Advanced Defense Studies. Steve is a member of the Information Systems Audit and Control Association, International Association for Cryptographic Research, and is co-founder and officer of WASC, the Web Application Security Consortium. So, Steve, you're a real expert here, and we are so thrilled to have you. Thanks to Amazon Web Services and Intel for supporting today's viewcast. So let's get right to it. What are you seeing in the government when it comes to cloud computing? How are agencies evaluating these newer technologies and capabilities?
Thank you, Constance. I think one trend we've seen is that a lot of government agencies have already deployed internally private cloud-style architectures. And what they're piloting now is looking at both hybrid and taking advantage of FedRAMP certified public cloud as an augmentation to what they've already done inside. They want to get that full benefit, but they're taking sort of a measured approach to going onto the cloud. As was mentioned in the panel, they've been tracking some 160 organizations that have already moved things into the cloud, and we're going to see continued growth there. But I think the key thing is to look at what are the right applications to bring to cloud. So some of the ones that have already gone either to a hybrid or full public cloud approach have been things like DevTest, desktop as a service, and PaaS or platform as a service kind models. What we'll see going forward is just because of the sheer volume of data and the amount of compute necessary, big data applications will be the next big wave that government agencies and departments are looking at as far as moving into the cloud and taking advantage of the scale and elasticity that cloud provides. So we'll start to see those kind of applications both moving from private to hybrid as well as taking the full advantage of the public cloud infrastructure.
Well, that's really interesting. The panel before us also focused on how adopting cloud computing has changed and is really changing the federal government. I'm curious what you are seeing in the foundational security considerations that we have to consider as we move forward with advancement of cloud computing in government.
Well, I think there's a couple ways to look at that. Number one is to look at some of the core building blocks upon which then you build your controls, and this could be in both internal as well as what the cloud providers need to be able to provide. Technologies and security building blocks like hardware root of trust and attestation, crypto acceleration to really make the cloud a secure foundation, be able to prove that security and trust to the tenants and to the other cloud service providers, and to make sure that your crypto operations run at speed. But from there, then you start to build the controls, whether using things like the FedRAMP and FISMA 853 style controls, as well as some of the more cloud-specific kind of technologies, like mapping your workloads into a set of policy management controls and then mapping that to the cloud orchestration allows you to take full advantage of the cloud while still being able to maintain the control that you want and be able to prove from a compliance perspective that you're doing the right things with your workloads and data. As was mentioned in the panel earlier, they were talking about SLAs and about portability. I think that portability and interoperability, both between cloud and as well as cloud infrastructure, is an absolute key enabler for going from private to hybrid and public cloud, so that tenants, the government agencies can move workloads in and out of the cloud across different cloud providers. And when they can map their policies, security controls, and compliance requirements into those, into that portability of the virtual systems, it allows them to be able to seamlessly move between those environments, make better decisions, and be more elastic with how they take advantage of these new services.
If we turn the conversation over to focus more on SDI, or software-defined infrastructure, can you talk a little bit about innovations that are driving next architectural changes?
Sure. I think one of the things that we're seeing on the customer side is that a set of technologies and innovations that the cloud providers themselves have been doing for a number of years. So this is how the Amazons and others have gotten that level of efficiency, is by using software-defined technologies like software-defined networking, software-defined storage, and software-defined infrastructure. What we're seeing is these technologies are now making their way into the actual departments and agencies. They're evaluating, how can I take advantage of those same capabilities for my private cloud, and then hook the two together in this hybrid approach so that I can be more dynamic with my networks and with my storage, and make better, more API-driven dynamic decisions around where workloads go and how data flows through the network. I think one thing to keep in mind is with every new architectural change, of course, it brings new challenges. And pick on software-defined networking as an example. Software-defined networking really is going to allow us to be more dynamic and more responsive with the network infrastructure, moving from brittle siloed style network architectures to a much more API or software-driven approach that can give you context-aware networking, context-aware security. So there's some really good benefits both from a security and efficiency perspective. But it also introduces new threats and new surface areas of attack. And so we have to be very careful as we implement these technologies to look at, how does this change my security posture? Where do I apply my controls? In an SDN environment, I need to look not just at the control plane, but now also at the data plane, because they're being separated. At the same time, SDN and software-defined infrastructure as a whole provides us a really interesting opportunity. Security has classically been a problem of bolting it on after the fact. But with these new technologies, I can start to design in my security controls as part of the actual fabric that I'm servicing my workloads and my data. And when it's part of the fabric, you can start to make context or data-centric decisions about what security controls you want to instantiate at the time that the workload's being provisioned. So I think there's both a challenge and an opportunity here with software-defined infrastructure. We need to make sure that it does no more harm than what our current infrastructure does. But if we do it right, we have the opportunity to help solve some of our lagging problems of how do we get more efficient with deployment of security, as well as the networks and storage and infrastructure that we're providing. So I think there's both a positive and a negative there. And if we get it right in the early stages, we'll be able to take advantage of what the innovation will provide from both a quality as well as a security perspective.
Well, and so the innovations, I mean, in your mind, how are they helping and how are they hurting some of these new innovations?
I think from a helping perspective, it's allowing the workload owner or the business owner to make better decisions about what network and security and storage requirements they have to programmatically create that infrastructure at the time that they're provisioning their systems into either the private or public cloud. So you're combining the people who understand the workload and what its needs are, and giving them access to define their network. So taking the burden off the IT infrastructure or the service provider from having to figure out, okay, what does this data or this workload need? It allows the workload to help drive that. So there's really opportunity to get better at deploying the right infrastructure at the time that you're deploying the workload and data. At the same time, it does take control away from those IT organizations as far as how you set the security policies. So there has to be some collaboration between your operations teams and your lines of business to make sure that you implement the right security policies, and also that these technologies themselves are robust enough and enterprise ready in order to be able to provide the right security and manageability features. We're seeing a lot of innovation here. There's a lot of really good tools, both open source and closed source. The key is to make sure that we actually lock them down and get them to be secure before we move on.
Well, Steve, thank you so much for joining us from Portland today for this, and thanks to our audience for tuning in today. This viewcast will remain online for the next 3 months. If you'd like to view the event again or share the archive with your colleagues, I'd like for you to have a happy day, and thank you all for joining us. Thanks. We'll see you next time.